friends. We are very happy to see you here today, and we are going to give a talk on 4 approaches to reducing Java startup time. But first, let us introduce ourselves. My name is Edelveis. I'm a developer advocate at Belsoft. I'm a Java developer. I love Spring, obviously, and JavaFX. I'm a tech writer, YouTuber, and you can find me on various social networks such as X, Blue Sky, or LinkedIn.
And my name is Pasha, as you probably saw in your program. I'm also a developer advocate at Belsoft. What a coincidence, right? I'm like 15 years in JVM development, mostly in Java and Kotlin, but I also used Scala, Clojure, you name it, and I have significantly more complicated relations with Spring than just love it. Also, you can also find me on Blue Sky and Twitter, and together we are
the Belsoft Devrel gang.
Yeah, we are.
Yeah. All right, so you might be wondering, if you have never heard about Belsoft, what the company is about and what we do. So Belsoft was founded in 2017, and we are the members of various committees, groups, boards, and foundations.
And the main thing you should know about Belsoft is we have Liberica JDK, also Liberica Native Image Kit and Alpakita Linux, but the Liberica JDK is the one JDK officially recommended by Spring. That's Arova. Let's move further.
Yeah, and well, that's enough about us. We are actually here to tell you a story about you. Right, but first, 4 quick questions. Who knows one way to reduce the startup of their Java application? Okay, quite a lot of people.
Who knows 2 ways? Nice.
Nice. Okay.
It's a little bit less.
Right. Who knows 3 ways? Okay.
What about all 4 ways to reduce startup time of your application? No one knows. Okay, so this talk will be useful for all of you, even those of you who do not use Spring at all. Let's go further.
Yeah, and so we really hope this is going to be interesting for you, because we are going to tell you a fairy tale. But it's not just one simple fairy tale, it's a fairy tale where you are going to be the main heroes. So, just like any fairy tale, ours starts with once upon a time. Once upon a time, all was well in one startup.
And this startup used, let's call it established stack of technologies, Java, LTS, not cutting edge, but good enough. Spring Boot 3.4, SpringIO, who uses SpringIO here? Who knows that Spring just released 1.0? Yeah, nice.
Nice.
Did we try it already with our code?
No.
No, we didn't try it yet. Also, we use MongoDB, Redis, JT for view rendering, and obviously we deploy everything here in the cloud. We use static generator for JT. We do not have any dynamic reflection here. We use JT templates like this. Let me show you the application itself. It's not your usual hello world you usually see on demos like this or on talks like this. We actually have 2 modules. First of them is called Bot Assistant. It's like simple one. I can tell hi if I can manage. Yes. And if I will ask it again, come on. I won't ask it again, right? Yes, the answer will be exactly the same, because we have a cache in our thing. Like, our startup is very usual to these days. We do something smart with AI. We are trying to solve some of your problems with AI. It's not important which problems. We just do it. And obviously, to optimize our costs, we cache a lot of things in Redis. So when AI answers something to you, we don't want to send the same question to AI twice. Why would we spend our precious tokens? We count our AI requests, cache responses, and so on. And the second application we have is, the second model we have is chat assistant. This one is slightly more sophisticated, let's call. It is actually a chatting application where many people can enter in the same time and communicate with each other and with bots. And we have Spring security here. What's it? Admin
1, admin pass 1. Yeah. We're not going to change your password, yeah.
Hi. Yeah, look, it just works. Theoretically, you can enter the application right now, and we can chat there together. We can see all the sessions we have open to our application right now. We can see all the chat history unencrypted, which is, I think, just beautiful. Because, well, we need to know what our users are asking, right? We can manage users, obviously, delete them, create them. So it's not a CRUD application. Like, it has a lot. It's 2 modules. This chat history and everything about users is being saved to MongoDB and so on.
And of course, as we are deploying our applications to the cloud, we are using a Docker file. And our Docker file is pretty straightforward. So we are using Liberica runtime container, which is based on Liberica JDK and Alpacete Linux. And we are simply packaging our application, and then we are transferring the jar file into a fresh base image, and we simply run it with a Java jar. And so at this point, the startup of both services together takes about 6.5 seconds.
At this point, you should know that one service is depending on another. Chat API is dependent on bot assistant. We deploy them together, so we measured sum of startup times.
Right, and the great news is that we are growing. We have so many new users, and of course, we are going to scale the services to meet the traffic.
But there is an issue. 6.5 seconds for kind of small-ish applications is long time. What if you need to roll out to thousands of servers?
Yeah,
what
so
if we actually need faster feedback loop?
we are an agile team and we need a fast feedback loop, so for that we need faster rollout. But the longer the start, the slower the rollout. And I don't know about you, Pasha, but I've been hearing talks around the cooler saying like maybe Java is not cut out for the cloud, or maybe it's not too late to migrate to Go.
Who is agree that Java is not cut out for cloud? Yeah, correct question. You are smart ones. I like it. Maybe it's true, but we will try to prove it wrong. Actually, you will try to prove it wrong, because you will be in one of the, or maybe more, of these roles. That's Defender, the Sage, the Explorer, and the Rebel.
Yes, and they all are very different, of course, but they all have something in common. They care about their software product, and they can't sit idle in the troubled time. And that's where actually you take the stage, because you will definitely recognize yourself in one of those heroes.
Are we leaving?
So,
No. Oh, you are leaving.
yeah. So, the first hero is the Defender.
Left hand.
And the Defender has the motto, right? I want painless integration with no incompatibilities.
So what do you defend?
Sorry, folks. I defend our application. Sorry. That's just the cup. So I defend our application. I don't want it to break. I don't want to refactor the code. And I don't want to solve any issues if we introduce a new solution. So
What's your idea?
what I found is the feature called AppCDS. It's pretty straightforward. So it saves the class metadata to the disk, and then the JVM reads the metadata from the archive. And it is even better with SpringIO, because this way we will load even more classes. And you know what? SpringIO is so good that we are going to use it from now on for all other solutions.
Actually, you could use it even without all of this 4 ways to optimizing your startup time and still be faster by a fraction. But
Yeah.
also, if you want to learn more about AppCDS, there is a YouTube video on the right side of the slide. You'll have the link to slides. You'll find the link to the slides in my Twitter, in Catherine's Twitter, whatever, and you can watch it. There is a lot of interesting stuff happening in AppCDS.
What I love about AppCDS as a defender is that there are not so many limitations. I mean, all you have to do is use the same JVM, use the same class path, and well, the Docker image is going to be a little bit bigger because of the archive. So let's take it for a spin. What we do is we enable AOT processing, And then we are going to change our Docker file a bit. So the first stage stays the same. We are packaging our application, and then we are extracting layers from our application. And if you would like to know more about layers, you can ask questions after the talk or come to our booth and we'll tell you all about it. So, but the principle of layers is that there are 4 default layers which are ordered in a certain way. So, when you transfer 4 layers, which are the dependencies, Spring Bootloader, snapshot dependencies, and application, to the fresh base image, the pool is going to be faster.
Why the order is this?
Well, because the most frequently updated layers are placed on top, which is the application and snapshot dependencies. And the dependencies and Spring Bootloader are placed in the bottom. So, if they are not updated, they are pulled from the cache. Right. Then, what we do is use 3 simple flags. First of all, we enable SpringIO. Then, we say, please archive classes at exit. Well, of course, not please. Please in Java world is just -XX, right? But then we use a very cool Spring feature called Spring Context Exit on Refresh. This feature enables the application to exit automatically as the Docker image is being built, so that we don't have to do it manually. And the application exits as soon as all non-lazy beans are initialized.
So what happens here after you call the Java command? What will be?
So the application starts, then it exits, and then the archive is being created. And so in the entry point, when you actually run your Docker image, you will already use the archive. So here we also enable SpringIO. Then we use another option, shared archive file, and point to the created archive, and then call our favorite Java jar.
It looks very simple, actually.
Yeah, and you know, the results are quite inspiring for a feature that is so easy to implement. So as you remember, both services start in about 6.5 seconds. If you use AppCDS without SpringIO, the startup is better by about 1 second. And if you use AppCDS with SpringIO, the startup is better by about 50%.
Yeah,
which is
factor of 2,
not
which
bad.
is quite impressive for a defender and for such a conservative measure. I like it, but the thing is, these defenders always live in present, but the sages like me want to live in future, right? I need for us to be prepared to what's coming next. What's coming next? Java 25.
So what do you propose?
It's not me proposing, it's actually a huge jab in Java. It's called Project Leyden, and it's already there, it's written, it's not merged yet. And some parts of this Project Leyden are already implemented, actually. One of them is called AOT cache. AOT cache is kind of works the same way as AppCDS, but it saves more. It saves pre-compiled code into the archive too. But obviously there are issues with the project Leyden itself. Not issues, but you should be ready. It is still in the makings. So if you decide to try it, you are kind of on your own, like me, because you know the sages in their high towers are usually alone. And well, we'll see.
So let's
experiment
yep.
a little bit.
Yeah.
The job I was talking about, the first, ahead of time class loading and linking, is called JEP 483, and it's about the idea, let's link a lot of things in our runtime, in our training run, recorded, and then we will create an archive like AppCDS does, and we will use it then. And the flow is very, very similar, but you can notice I switched to Java 24 now, because AOT cache was introduced in Java 24. I split my application into the layers, I copy the layers, but then I do not call my application once, I call it twice. First time I need to record its activity, which is -XX AOT configuration app.aotconf, and then I have to create an actual archive with this activity with -XX AOT configuration equals app aotconf and AOT mode equals create. After that, when you will start up the container, it will be Java SpringIOT enable true, obviously, -XX AOT cache equals app.aot, and then our app.jar. And this is kind of impressive. So just by jumping from Java 20, like conservative Java 21 to Java 24, using one more command line argument, you cut your startup time more than twice, which is very impressive in my opinion.
Oh, the wisest of the wise. Tell me, what do you expect from Project Leyden on the whole?
We can foresee the future, kinda, because it's all written in JAPs. There will be condensers. Condensers are different modes of optimizing your code, and you will be able to enable or disable some condensers. They will put some limitations on your code if you are ready to do it, but they will also tremendously trim startup time of your application, or not. Also, if you find any bugs in it, just report them, please. It's very important because it's done for you.
So maybe you will tell us how to use Project Leyden.
Project Leyden is very simple to use, but there are no early access builds of Project Leyden from Bellsoft, so we use Oracle's ones. We just create a new stage called downloader, where we download and unarchive our Java. Then we will use this Java all the way down in all the stages. We will copy our Java and use it as our main Java. So first we will build our application, then we again extract layers of our application, and now we copy not only Java but all the layers from our application, and we again use a different command line argument, -XX cache data store application.cds, which kind of reminds of AppCDS, right? Well, future is sometimes very similar to our present. And this is how we start up our application. Java-cache data store equals application.cds -jar, and this is the results. So if you look at it, then AOT cache is more than twice better than usual startup of our application. But with Leyden early access plus SpringIOT, we actually cut the time of a startup 3 times, which is crazy, given the fact that we still didn't need to change a single line of code. I mean, the future looks bright to me.
Well, this is all very well, but I'm going. Now, I actually feel adventurous, and I found something exciting that I can't wait to explore. And this is something is GraalVM native image. GraalVM sounds very romantic, you know, like Holy Grail. It reminds you of Arthurian quest, Lady of the Lake, yes. So, and dragons maybe on the way to Holy Grail.
And probably Excalibur a little bit.
Yeah, probably. So, what is GraalVM native image all about? It's about ahead-of-time compilation. So, Java applications are compiled and optimized at runtime. That's why we can run a jar file at any platform. GraalVM native image gives us ahead-of-time compilation. So, the code, the Java bytecode, is compiled to a platform-specific binary. So you get a standalone executable, and you don't need any OpenJDK distribution to run it, because it already contains the necessary JVM classes.
It sounds too good to be true. Does this promise of write once, run everywhere works here, applicable here?
No, it won't, because you build a native executable for a specific platform. That you should keep in mind. And also, this is a very resource-demanding process, so you need to allocate several gigabytes of memory to that and wait for several minutes before the image is built.
Is it a full-blown Java? Can I use all this reflection stuff and so on?
We have configuration files.
How do we use them?
Well, we write configuration files.
Nice.
Right, but let's just finish the talking. Let the journey begin. Right, so let's first try to build a native image locally.
How did you build the fat jar you're talking about?
With a Spring Boot plugin.
Yeah, Spring Boot jar.
Yeah, Spring Boot jar, exactly. So you're building a fat jar, and then you can use the native image distribution, such as, I don't know, library native image kit, for instance. And then you use the native image tool inside this binary, and you call your favorite Java jar, right? So we are using our fat jar.
So it's almost like calling Java.
Yeah.
But native image.
With the native image. So
and it should work.
And the image was built. I mean, let's run it. You know, I actually never thought that the journey can be so pleasant. No issues. So
I mean,
cool.
I like it. If it already works, I'm pretty happy
yeah.
with it.
Uh-oh. Oops.
What
That's
happened?
our first dragon.
What was it?
Right, so we have an exception, zip exception, zip and header not found. So I researched. Apparently, it's a known issue, and it is recommended to use Maven plugin instead of the native image binary.
Why?
Because the Maven plugin calls the native image jar command under the hood, but it also uses lots of flags that solve problems like this one above. So the Spring team did a very, very tremendous job actually to make this process more smooth. So let's try it with a plugin. And the great news is that if you use Spring Boot parent POM, the native image profile is already configured for you. So in the best case scenario, you just need to enable it by simply running maven pnative native compile.
This is what I see in all the nice demos of native image.
Yeah, so I think this is going to be like super smooth. I mean, oops, another dragon. Right, so what do we have here? Classes that should be initialized at runtime got initialized during image building. Right, but this is a very stupid dragon
What
because
does it mean?
it gives us the hint on how to kill it. So it actually means that some classes that should be initialized at runtime, well, got initialized at build time for some reason, and we are going to...
We don't know what's the reason.
Well, again, this dragon is very stupid. It gives us the hint how to find out the reason why these classes got initialized. So, in this case, we need to actually add the native profile because we need to configure it a bit. So, that's the profile native, and we're using the plugin GraalVM build tools, pointing to the main class of our application. And then we use the trace class initialization argument as a build argument and run maven pnative native compile again. Okay, so that's the same issue. We were prepared for that, but now we get the more detailed output. So it says here that the class called XML event decoder caused the initialization of the classes that caused the trouble in the first place. So we found the culprit. The only thing left to do is to add the option to initialize this XML event decoder at runtime, and well,
It's simple.
yeah, it's quite simple. Initialize at runtime.
You know, I'm just guessing why they didn't do it themselves, because like they can say you that you need to add the argument. Why can't they trace it like from the very beginning?
Well, the history is silent at that point, but I think now everything is going to be okay, right? So let's run maven pnative native compile again. Oops, that's the same dragon. So that's exactly the same exception.
Wait, what's happening now?
That's exactly the same exception. So the classes got initialized at build time again.
But
the option didn't help. Yeah, well, that's one evasive dragon, I might say. Right, well, apparently that's another known issue. And this XML event decoder was, well, really hard to kill. And we need to add the strict image heap option. Actually, it is enabled by default in native image starting from GraalVM for JDK22.
Sorry, I will interrupt you. It's not just enabled by default. It's enabled by default and removed starting from GraalVM in JDK22, which you can see in the source code, even though they don't say it in the documentation.
Yeah, but as we're using JDK21, we still need to enable this option to that requires that only the classes stored in the image heap to be marked with initialize at build time. All right.
I
Well,
want to say
anyway.
that this way of Explorer is crazy hard. we should fight the same dragons over and over.
Well, that's just one mighty dragon. I mean, that's okay. We are on the quest for the Holy
Yeah,
Grail.
like
Nobody said it's going to be simple. So let's add the strict image heap option. Yay! Success! Right.
So now I guess.
Yeah. Well, we've built the image successfully. So
Yes.
now let's run it. Oops! Another dragon. Okay. What do we have here? The unsatisfied link error Java JDK GFR is excluded. Apparently, when we create a connection to Redis, Spring creates a custom GFR event, and GFR was not included into our image.
Wait, won't tracing agent help you in that?
Unfortunately, no. Even this tracing agent can't detect the usage of GFR in this scenario.
Or it detects and doesn't care and doesn't tell us that we should
Yeah.
enable it.
So in some cases, you need to enable GFR explicitly by adding the option enable monitoring, right?
Yes.
Okay, so let's try again. Fingers crossed.
How many options it is already? It's
There's just
three.
two options: strict image
Okay.
heap and enable monitoring. So easy
Nice.
peasy. Yeah.
Not that bad.
Yay! Finally, everything works.
So it runs.
Yay! On my machine. Yeah.
Come
Cool.
on. Come on.
Well, yeah, I
Works on
built
my
the
machine,
image
really.
locally. Yes, so let's move on to building a native image in a Docker container. I mean, it's going to be super easy. We solved all the issues.
We'll just repeat the same command, right?
Yeah, just in the Docker file,
Yeah.
right? So we are going to change our Docker file a bit. We are now using Liberica Native Image Kit container with Liberica Native Image Kit and Alpakita. We are running the same command, pnative native compile. We already added all the necessary options to the Maven plugin profile, sorry. And then we are just copying our executable into the fresh base image with Alpakita only, because we don't need OpenJDK.
We don't need anything.
No,
like it's
no,
self-contained
only
thing.
Linux, and then we just simply run it. All right, let's try it.
Yes, let's do it.
Yeah, let's do
Let's
it.
do it.
Yeah,
I
yeah.
think everything
I'm
should
hopeful.
work.
I'm hopeful. Oops, another dragon. Right, so this time compilation exceeded 5 minutes.
How the hell compilation runs 5 minutes on your machine and what we can do?
Yeah, so well, the build was taking too long and it never finished, basically. There are several solutions to that. So you can increase the timeout time to wait for maybe 10 minutes.
I like it. If you have a big application, you'll say we have a timeout of 2 hours. And
Or
not
you
a
just
build.
want to take a nap.
Yeah, I mean, you still
yeah.
need to put timeout in there, right?
You can build a native image on a more powerful PC or in the CI. So I'm using an old M1 Mac. So I guess it just wasn't cut out for it. Or you can plug a laptop into a power socket.
Are you telling me that when you were building and developing the whole application, you didn't plug your laptop into the power socket?
No.
Who's like hell?
Oh!
Well, yeah, two people. I
All
see
right,
you.
okay.
I respect the bravery. This is very cool.
Right. Okay, so I plugged in my laptop into the power socket. Let's give it another try. Oops, another dragon. Right, hopefully the last
come on,
one.
it's already in the power socket.
Yeah, I mean, that's a nest of dragons, you know. Okay, so here we have a runtime exception, an error linking the native image. Well, apparently, it is a linking issue related to the muscle library that lacks required tools for linking the native image. And again, we have two options. You can add required packages to muscle with the APK add, or you can switch from muscle-based Alpakita to glibc-based one. And we're only changing 2 lines in the Docker file, and that's basically it. All right, fingers crossed or what? I mean, really.
Try. I do not believe you anymore at this point.
Okay, let's just try. Who believes that this was the last dragon?
Yeah.
Okay,
they,
you want
they
a
know
couple of
us,
person.
they know us.
Yay, we did it. See, we did it. Both services compile and run successfully.
I do not hear applause. Thank you.
Right, well, the results are quite impressive. Both services start in under 1 second,
Slightly over, each of them.
Each of them in under 1 second, and both together in slightly more than 1.5 seconds.
So we cut our startup time 4 times.
Yeah, that's a good result, I think.
That's impressive? Yeah.
Yeah, well, it's over.
I mean,
that was
your way. I would not like to be an explorer because at this point I'm almost dead. I don't have a single nerve in my nervous system.
That was one hell of a journey, but it's quite memorable one.
But I think it's actually not only memorable, but boring. What do I say? Hasta siempre?
Hasta siempre.
Hasta siempre. Hasta siempre. Because I'm a rebel. And I'm not ready to settle on half measures. We will fix this thing to its death. And for that, we will use that tool called CRaC.
Sounds like a drug.
Sounds like a drug. Well, Che Guevara, what do you want? And I'm a rebel. This is how I have all these ideas in my head. CRaC stands actually for Coordinated Restored Checkpoint. And the idea is very simple. Why would we do all this magic at startup when we can start our application, look at its memory somewhere, I don't know, 500 megabytes of memory, gigabyte of memory, and dump this memory to a hard drive. And the next time when we need to start our application again, we won't launch the JVM, read the classes of our application. We'll just restore the memory altogether. Eventually, it is what the application is, right? And like, I am trying to give many promises here. First, you'll be able to pause and restart your Java application. Second, a snapshot of the current JVM machine will take some place, but it's significantly faster to recover from than, I don't know, launch the whole application from the very beginning. And the third one, the thing that native image doesn't have, you will still have all the nice things of JVM, like JIT compiler. Native image is amazing, don't get me wrong, but boring.
Well, rebels, of course, give a lot of promises, always. But actually, Pasha, I don't believe you. I don't believe that we can reduce the startup of a Java application to mere milliseconds and still have dynamic performance optimization. I mean, really.
You shouldn't believe me, because I can prove it.
Okay.
But
you're
kinda right. You're kinda right. There is a but, a huge but.
Oh. Huge but?
Yes.
Are you hinting or something?
Yes, CRaC. It's not a canonical part of JDK. It means that if you download your JDK from, I don't know, Amazon, or let's say OpenJDK from OpenJDK.org, there won't be CRaC implementation in it, won't be CRaC support in it, or Tamarin, whatever is popular these days. Probably it won't work. Actually, it will work on only 2 JDKs. First of them is Azul JDK, Zulu. They were the first to implement support for CRaC. And the second is ours. Well, it's kind of advertisement. We maintain fork of what Azul did. And also, remember I told you that we will make a snapshot of the whole memory. What do we store in our memory?
Sensitive data.
We store a lot of sensitive data in our memory.
Passwords, whatever.
OpenAI keys, like we do in our applications, session tokens, whatever. You start the application with all this stuff in your memory, which is a good thing and a bad thing too. If someone finds your snapshot and is able to run from it, and it's actually very simple, they will have all your secrets eventually. And also, again, I am not about settling on half measures, right? You will probably need to change your code. All the previous changes were boring and non-invasive. We will have an actual surgery here. Like, we will dig into this stuff. So, the trivial example comes first. Trivial example looks like this. We have public static void main. Hey. And we have start time of our application. Then we have a counter from 1 to 10,000. In every iteration, we sleep for 1 second. Then we get our current time again. And then we print current counter and difference between current time and start time. And then we obviously override the start time. This is just a nice demonstration just to show you that actually when you will recover from your CRaC snapshot, there will be a huge difference, like seconds, minutes, whatever it is, between current time and start time. And Dockerfile is actually very simple. It is so simple.
That is not that simple.
It's not that simple. But let's look at it first. First, we have to change our JDK. We have to use JDK 21 CRaC something. Second, we add our Java file to, since it's just a simple demo, right, to an application. Then we compile it. Then we run our Java with -XX CRaC checkpoint 2 app checkpoint and name of our application.
So does it create the snapshot?
Nope.
No? Okay.
Nope, it doesn't create anything interesting. It just launches the application, launches the Java in a mode when it's possible, theoretically, to create a snapshot. But then, it is kind of straightforward. We build this image, right? We have tag, pre-CRaC, we have our file, and so on. We run our image. At least we would like to run our image, but if we will try to snapshot image when we launch it this way, it will actually fail because we need some permissions, and to work it around, we'll do something like this. Who knows what's wrong here? Okay, they don't know.
Knock, knock.
Who is there?
The security team. What the heck are you doing running the containers in privileged mode?
Well, you know, I just need a couple of capabilities.
Yeah.
Just need to do a CRaC snapshot. Like, she means they won't be happy. It will work, but they won't be happy. But I will try to solve it the way that it will.
Oh, really?
We both will be unhappy, but still better than double dash privileged, like this. I will add two arguments, cap add, cap sysp_trace, and cap add, cap checkpoint restore, which actually will work. It is a minimal necessary set of capabilities we need to create a checkpoint of our Java application.
What do they do?
Cap sysp_trace does very simple thing. It allows our application to look at the whole process tree of the operating system, just to know who launched it and what descriptors are open and so on. And cap checkpoint restore, I don't even know why it is a separate capability, because in my head, anything should be checkpointable and restorable. But still, it exists. We need to report to operating system. By the way, as you can imagine, it's Linux specific. It won't work on Windows or Mac, but it will work in Docker because it's on Linux there. Then, now when we all know all this smart stuff, here is what we do. First, we launch our application with two capabilities, as was agreed before. We wait some time. We need for application to start up, to load all the pins, and so on, right? Then when we have waited for some time, for example, we can wait until all the ports necessary are open. We execute inside this very container command jcmd 129.
What's jcmd?
JDK checkpoint. JCMD. It's a magical. Who knows JCMD? Oh, folks, you need to look into it. JCMD is beautiful. It allows you to do anything to Java, like in runtime, add an agent in runtime, for example, to it, or do something else smart. Here, what we do, we are saying to process 129, which is a magical number, obviously. When you launch your Java application inside Liberica container, it will always have a process ID 129, and then we are saying checkpoint and please. It will kill the application with non-zero exit code, but we do not care anymore, because at this point we can just commit it to our local repository. Now to launch it, we need not so many things. We can Docker run it. We have to redefine entry point to Java. Then we put there our tag. And then Java has only one argument, -XX CRaC restore from app checkpoint. We don't even need to have jar file to launch our application. We need only Java. which is,
So-
in my opinion, beautiful.
Does it mean that we can actually crack our services just like that?
Of course, it just works until it doesn't.
Yeah, sure.
I mean, you had the same in your story, right? Don't blame me.
Fair enough.
So, in our startup, with 2 modules, bot assistant, it just cracks, it just works. No magic there. Chat API doesn't. But because only some projects are guaranteed to work, I see. Only some projects are guaranteed to work. Spring team supports something, but for example, they do not support MongoDB. As you remember, we have MongoDB support, MongoDB in our chat API. What are the options we have? First, we can fall back to another solution.
I don't like this option.
You should like this option. I don't like this option.
I like MongoDB, so
Well,
Find
fall
out
back to
something
another
else.
solution like native image, I mean. But we won't do it
Oh.
because we do not settle on half measures. We can request support from Spring team. They will be happy to get some of your money for this to be implemented. Or we can implement support on our own, which is not that complicated. Let me quickly run through it. Luckily, Mongo client is just an interface, so we can implement this interface. And we will have like our delegate field here that can be rewritten by something else. And we will delegate all the functions of real Mongo client to our Mongo client proxy. Then we will define a component which is actually a CRaC resource. CRaC resource is a thing that allows you to stop and correctly restart the application. Inside it, we obviously have a constructor that accepts Mongo client proxy and Mongo connection details. Who knows why do we need Mongo connection details? We need Mongo connection details to recreate the connection, obviously. And and also, we need to register our component as a CRaC resource. So when CRaC detects that we want to snapshot our application, it will actually gracefully kill our application. And when we will restore, it will do something like this. Mongo client proxy.delegate equals Mongo clients create details.get connection details. This is where we use the saved connection string. And then Spring has its own Mongo client, but we need to overwrite it because we need this CRaC support. So we'll have bin, primary, I don't know why it's not selected. So it's a primary bin of Mongo client, which we create out of the box, and we return new Mongo client proxy with our initial
so
client.
that's it, right? Well, was your rebellion worth the trouble? Oh, I see.
Let them decide. Let them decide. Was it worth the trouble? I mean, initial time is 6.5 seconds. Now it's 80 milliseconds.
Impressive.
And I betcha for bigger applications, if you can crack them, it will be very close because hard drives are actually very, very fast.
Right, so our fairy tale came to an end, and of course, they all lived happily ever after. A quick recap, shall we?
Yes. So if you identify yourself with conservative defender of your code base and of money of your company, you will probably go with AppCDS.
If you would like to wait for a little bit and experiment and gather knowledge, you can watch and monitor the project Leyden, experiment with early access builds, and prepare for the migration in the future.
And use AOT cache with Java 24 today.
Of course.
If you're feeling like Explorer, then you probably should go with native image. There will be some dragons in production-like applications, but if you can slay them, you win a lot.
And if you feel like breaking things for the sake of better future, you should go for CRaC. That will give you almost instant start. And heads up, guys, if you're testing locally, please use the power cord. Don't be like me.
How much time did you save when you plugged the power
About
cord?
1 second.
Like, I mean, it's a lot.
Yeah.
It's like 15% or more.
Yeah.
So this story came to an end, but your story just begins, right? So that after tomorrow, or whatever, Monday, you come to your work and now you know how to improve the startup of your real applications. Go for it.
Well, thank you. Thank you for your attention, friends. I'm afraid our time is up, but we are open to questions. So if you have any, you can drop them in the chat in the application or come to our booth, Bellsoft, on the first floor, and we will be happy to answer all of your questions. Bye.
You can come
Have
back
a
here
nice
too.
day.